Now, as we start topic 1 of Module 4, Radical Expressions, Functions and Models, a little background information. We'd like you to copy this into your booklet. First of all, this particular sign, this is referred to as the radical sign. Now, this is sort of like a plus, a minus, a multiply, and divide, and absolute value. This is an operation. It is take the whatever this sign indicates of the number that is under it. Now, the number that is under it, let's say it's 4. This 4, or what is under the radical sign, is called the radicand. So a useful word, we'll be using it from time to time in this module. Now the other word here is the index number. Well, the index number goes in this little notch of the radical sign. Now, right now there isn't a number there. Well, when there isn't a number there, the number is 2. If it is a 2, we don't write it. All right, so 2 is the index number. Now, other index numbers can be found there as well. For instance, 3. This would indicate take the third root of 4. And others are found there as well. You can have any number here, 7 or 4 or whatever. So whatever number is there, that's the index number. If there is no number there, it's a 2. That is the square root of something. So once again, the radical sign, the index number, and the radicand. Okay, now we're going to be doing these, and as I model them, we'll give you some background and answers. So the operation here is to simplify. So we take the square root of 49. What two numbers multiplied together give you 49? And that is 7. Now later we'll know that it also could be a negative 7. That in a sense we're squaring to get 49. But here we're looking for the principal or non-negative square root. Alright, so when you have a fraction, you take the square root of 9, which is 3. Square root of 100, which is 10. Now here, because of the negative sign, whatever answer we're going to get will be negative. And then the square root of 16 is 4. Now here, because of the decimal places, we have to figure out something that's going to give us 4 decimal places. So it'll be 0.02. So 2 decimal places multiplied by 2 decimal places give us 4 decimal places. And 2 times 2 is 4. Okay. Here they want us to do some substitution. So the square root of 5, or I should say the square root of 5 times x, which will be 7, plus 1, is the square root of 36, is 6. Now, for this one, we're going to put a 20 there, and it's negative square root of 4 times 20, which will be 80, minus 3, will give us the square root of 77. Now there is 77 is not a perfect square, so we just leave it in this form. Now keep in mind, when it's not a perfect square under the radical sign, the number is what we call irrational. Now in the above examples, we said we were thinking of the principal square root, but here they're assuming that it could represent any real number. So we have to say it could be a negative. So theoretically, we could divide this into two parts, the square root of this and the square root of that. And we see that here we have a 81. Now the answer that they give below is 9. And then z, for z they have put absolute value signs by, because that z could have been a negative and a negative to give you the positive. And I would think too that the 81 could have been a negative 9. So this is the answer. So this is a little tricky. And if you get something like this on a test, I will give you, possible partial credit. But again, when you do the practice, look how they want the answers, and then follow that model when you take the test. Now, for letter B, remember this, what we see under the radical sign, the radicand, is a perfect square trinomial, which factors into that. So when you take the square root of this, you're going to get y minus 3. But to ensure that you get the negative values as well, possibly, they have put absolute value signs. That's the answer they give below. Now for letter C, as you look at this, and let me give you something we're going to be doing in the next section that'll be useful for something like this. Now, what is our index number here when there isn't one? Well, the answer is 2. Now, whenever you're asked to do something like this and you're wondering, take this index number and put it under the 12. So we have 12 divided by 2, which will give us x to the 6th. Now, for some reason, they're not putting the absolute value bars there. And again, that's a little tricky. In example 3, notice our index number is now a 3. So we're taking the third root of these. So let's do some substitution. 2 times 32 is 64. And you may remember from an earlier lesson, 64 is a perfect cube, and that equals 4. Because 4 to the third power is 64. And in this case, we're taking the third root of 128, a negative 128. We're going to add 3 to it, so this becomes a negative 125. Now, you may recall from earlier lessons where if we have the square root of something, or there's an even index number, you are not allowed to have a negative under the radical sign. Why not? Because when you multiply, now the 81 is a perfect fourth. If you multiply -3 times -3 times -3 times -3, that is, you're using this value 4 times, it's going to end up being a positive. Now, if they are positive, then it is, of course, a positive. Now, here, 125 is a perfect cube. And if we multiply it 3 times, a -5 times -5 times -5, this does give me a negative 125. So the general rule is if the index number is odd, it's okay to have a negative under the radical sign. If the index number is even, that is the square root of 2, square root of 4, square root of 6, and there is a negative number under the radical sign, the answer here is it is not a real number. The general rule, and again, take some notes of this. So this one is legal, and the answer then is a -5. So if you have an odd index number, and there is a negative under it, then the answer will be a negative. And for index numbers, 3 odd numbers, we would never use absolute values. So in letter C, the cube root of a -27 would be a -3, and then we're going to take the 3, the index number, put it under the exponent, 6 divided by 3, x to the second. Okay, we'll go on. Now, here we have the 5th root of a negative number. So that's an odd index number. So our answer is going to be negative, and it's 3. A -3 to the 5th power is a -243. So the reverse of it, where we take the 5th root, is -3. Now here we have the 4th root of 81. Now that is 3. And we take 4 and put 4 over 4. That gives us an x. Now the book is saying that we want to indicate that there could be negative values here when they say represent any real numbers. So that could have been a negative. Theoretically, the 81 could have been a -3 that we're doing it to, but for some reason they're doing it this way. So I would cut a lot of slack, but look at what the practice in Quiz Me is asking for, and then follow these models. Now here we have a negative because of the negative sign outside the radical sign. We're going to take our 6, put it as a denominator of the exponent, and this becomes then x minus 5. But since this expression is, the index number is 6, we should put an absolute value sign there to make it official. Now, odd index numbers, we don't have to do that. This just becomes A. Because we're going to find in our next section that another way to represent that is to take the index number and put it as our denominator here. And that's a to the first, which is A. Now again, 7 divided by 7 is 1. So when the index number and the exponent we're raising something to is the same, it just becomes the radicand. And because it's an odd index number, we don't have to use the absolute signs. Now, we spoke of this a little earlier. Here's an even index number with a negative sign under the radical. So that is not a real number. And you recall, this is the symbol for a real number. Now in example 5, they're asking us for the domain. So these would be values of x. Now in most cases, x is going to equal all real numbers. But we do have the exception when our index number is even, and here it's a 2, here it's a 2, here it's an even number. We cannot have what is in the radicand ever be a number less than 0. Because then that would make our radicand negative, and that's not a real number. So, in a sense, as we look at x and we're going to square it, any real number that is, let's say, a negative number that we square will always end up positive. So can you think of any value that when we square it is not going to be positive? And the answer is no. So for the domain of this, it will be all real numbers. Now, how do we write that in interval notation? Well, we said it was from negative infinity to positive infinity. Okay. Now for these, and we have done some of these before, we want to see what value of x would make our radicand negative, that is, less than 0. So we're going to find what are the values. So we said we take our radicand, and this is the strategy, write this down, is greater than or equal to 0. So we just transpose our negative 5, and we don't need that equal sign there. I got carried away here. There we go. X is greater or equal to 5. Now that means if x is 4, and we put a 4 there, 4 minus 5 is negative 1. If we put a 3 there, 3 minus 5 is negative 2. So in order for this to be true, where you can get a real number answer, our numbers have to be equal to 5 or greater than 5 in order for this to be true. So the domain of this would be, my wife is calling me, but anyway, so what would be the interval notation of this? Well, remember, if we put that on a graph, we're going to use a bracket here at 5, darken this, and it goes to positive infinity. So in interval notation, it's a bracket, 5, comma, positive infinity, and parenthesis. Okay, so for this, you know the model now, and watch what's going to happen. So we're going to say 15 minus 2x is greater than or equal to 0. Now, to keep our variable positive, I'm just going to transpose it to this side where it becomes a positive 2x. Now notice, in a sense, we've reversed the inequality sign, not by changing the direction, but by transposing the negative 2x. This equals 15. So when we divide both sides by 2, and I'll write it this way now, we get x is less than or equal to 15 halves. Now if we plot this on a number line, we get 15 halves. Now what sign do we use here? Well, a bracket, but this time it's facing left because it's less than. And you might say, well, that doesn't make sense. All these numbers over here are negative, but I'll show you why it does make sense in a moment. So how do we put that in interval notation? It's coming from negative infinity, and again right from the graph, and this is 15 halves, or 7.5, or 7.5, and then here we use a bracket. Now you might say, why is that true? Well, because as we look at our original example, it's saying a negative 2x. So if x is a negative value, which most of them will be, a negative times a negative makes them positive. Because of that negative sign here, a value of x that is positive, as these get bigger, will make what is under the radical sign negative. And it goes up to 7.5. So that's why that is true. Now, if you're not sure, we can talk about it some more, but look at it carefully. Any negative, let's say, let's use negative 8. And that's right after 7.5. Negative 8, negative 2 times negative 8 makes it a positive 16. Because if x is negative, a negative times a negative makes it positive. And that's why this is true. Okay. Now our last example, what they're looking for here is maybe I've hit the wrong button there. Anyway, this is our function. P of t is such that 34 the square root of x. So we're saying our sign company, its profits can be modeled after this function. Now, we're going to start in the year 2000, estimate the profit of the store in 2015. So the first question is, how many years is it been from there to there? And you might say, well, it's going to be 15. Exactly. So we go 34, the square root of 15. And you put that in your calculator, and it becomes 131,681, and there's a dot right there, but this is thousands, so we move the dot over to here, add a $sign, and we get our answer. Now again, they're not showing any cents, pennies over here, it's just this. Okay, so again, this one wasn't too hard. Hopefully your practice won't be too bad, but again, do the practice, do the quiz me's, earn your mastery points, bring any questions you have into class, and we're happy to help you out a little bit. Let's go on.